Hello everybody, and welcome back. My voice holds out through this. Let's see. Okay, guess we're on part 14. Going to work on explain the screen supply and what I'm using for a my voltage divider resistor. I have a 600 volt center tap transformer that I'm going to use for the screen supply, and when you ground the center tap and use just 2 diodes, that gives you 300 volts either side of center tap. So the 300 volts AC voltage, you multiply that times 1.414, and you see we have 424 volts DC across the capacitors and the bleeder resistors here. You might have something different, but our target voltage is around 350 volts. So I can't use all of this 424 volts for the screen voltage. That would be too high. So part of that gets dropped out. Now these resistors are 10K, 5 watt apiece. It isn't necessary to have that big a resistor. I'm just in the habit of using what I have on hand. So to get the resistance I needed is I just paralleled 3. They're 10K resistors each, so I paralleled them, and that gives 3,330 ohms for each little block. Our target current that we want to drop through this divider is right around 20 mils. And on this particular one, we're going to come out with about 21 milliamps, which is just perfect. The tube itself draws 10 to 15 mils, and the tetrode tubes will try to raise the screen voltage by themselves. They call it positive grid current. They'll actually try to push the voltage higher. So you need some amount of bleed going on, or the tube can go into what would be called runaway. The more current it tries to push, the screen voltage goes higher, so the tube conducts more current. When it conducts more current, it wants more screen voltage. The screen voltage goes higher, and there you go. You get a vicious circle, and the tube will go into runaway real quick. So you have to have something to hold that voltage down. So your bleeder current off your screen supply needs to have roughly 20 mils is good enough. Now this isn't turned on, but only when you transmit. That's what we got this little relay here for. Normally in receive, there's no power going into these resistors. It's essentially it's shut the screen voltage off to the tube, and that's during receive. I have a variac ordered. This thing would be my favorite. I would prefer to use this little variable transformer. It keeps it to where you don't have to use steps. You just vary it like a volume control. You dial it to where you want. But what I have is a switch, so for this installation we'll just use a switch. It's less than what I wanted. I showed just, yeah, it is 4-position, and I do have a 4-position switch. I wished I could have found another one. I could have had one more tap on here for a lower power, but it'll work out and it'll get the job done. And later, when I get the variac in, it's been ordered, like I say, it just hasn't arrived yet. This is a small one, and it's not quite what I want for the job. It needs to be just a little bit bigger than this. Okay, so this switch is going to tie into the first resistor down from the 424 volts. That's going to get rid of our voltage to the point to where we won't be over voltage in the tube, because each time you drop across the resistor, the voltage drops lower all the way down. The math behind that is total resistance with 6 resistors That's 6 times 3,330 ohms, gives us 19,980, a total of 19.98K. Okay, voltage, the math behind it. Voltage divided by the resistance. Voltage dropped across the resistance gives you a current. So to find that current, it's E divided by R equals current. So 424 volts divided by 19,980 ohms comes out to 0.021 of an amp, or 21 milliamps. So there's 21 milliamps of current being drawn through that. So now, current times resistance equals voltage. So a current of 21 milliamps times 3,330 ohms is 70.6 volts. So across each resistor, there's going to be a 70 volt increment all the way up here across each resistor. Now, the power, if you had a smaller stack of resistors in this, you would have to worry about how much power this is going to dissipate. Actually, it's not going to be much. Current times voltage equal power. So 21 milliamps times 424 volts is only 8.9 watts. So that's not really much. This resistor pack won't even get warm. Okay, so what I'm going to wire into the chassis, I've got the transformer mounted. This transformer will also give me my 6.3 volts filament voltage. Now that's something I'll have to change when I use a variac. I will have to disconnect the filament from this transformer and put a separate 6.3 volt transformer so that the filaments can always have full voltage all the time. Because this transformer is going to get varied with the variac to raise and lower the voltage. And this relay will then do a different purpose. I'll come back and show you how to change from this circuit over to where this relay is given another job. It'll actually be turning the voltage off and on to the variac itself. Here, it just simply turns the DC on and off to our divider stack. That's what we're doing. Okay, we'll pause the camera here. I'll get the chassis out and it'll give you a chance to see it. Okay, this capacitor stack I've got over here are all the capacitors that's going to be needed. There are 3 in a row in the back here. Those are for the screen voltage. This cap here that's kind of looks like, I don't know if you can see it, it's the tallest one in the stack. This one is going to be for our key-in voltage, our 24 volts. This cap here is going to be our first voltage that we're going to get out of the DC voltage for bias. It's just going to be, we're going to get some voltage out of the 6.3, and I'll describe that here in a minute. And this transformer is part of that. And then there's 2 more here for a voltage doubler, and the final voltage on this cap of our 50 some volts, I think is what we're going to have for bias, about 58 volts, I believe is what I had figured. And so now I'll let you see the other side of the chassis, the little transformer. Okay, this is the filament transformer for the 4CX250B to give 6.3 volts, and this is the screen transformer. And you see it where its position is in relation to the fan. The air box will go over top of the fan. The high voltage transformer is going to go over here with the high voltage capacitor stack in this area. And these are sitting towards the back of the cabinet. That's the front of the cabinet there. I haven't got anything mounted because I'm working this right along, so you're seeing exactly what I'm doing when I do it. So we'll get to that soon. We're coming just about done with the wiring of the stuff underneath. Okay, I'm going to put this away and I'll explain the bias circuit, how the transformers are hooked up. Okay, I think we're in focus there. this is the time when it gets to the point to where I don't know what you have available for your transformers setup. Everybody's going to have something different. There's a lot of tricks to use a couple different transformers if you don't have one that'll give the right voltage. You can do some tricks with voltage doubling. You can have two supplies and stack them. Here we have a voltage doubler. It's only 6.3, but we stack the voltage and then we can get a total of 53 volts. This one here is a 12.6 volt transformer. Not ideal, but it will get us close to what we want. The tube should have about 55 volts bias, but this at 53 volts will work. The fan needs at least 48 volts to run, so we're close enough for the fan to have what it wants, and the tube will be happy with 53 volts. We'll just have to, when you decide your bias, not bias, when you decide your swamping resistor, you'll tailor it to come out just a little under the 53 volts. That's how that works out. And then of course on this one, this is your filament transformer, so this goes to the filaments there. On this one, same idea, only an 18 volt transformer and a 6.3. Again, the 6.3 is the filament transformer, so we're making use of two of them to get our voltage. And with 18 volts and a voltage doubler, we're actually adding the 6.3 to the 18, and we're coming out with 67 volts. So this one will work out pretty good. The only problem with this one, you have to now use one more transformer to get your 24 volts of keying voltage. If you just rectified this is going to be too high. This is going to be almost 33 volts rectified out, so it's just a little bit too hot. This is a circuit I'm going to use because I have the 18 volt transformer. The 6.3 volt part of this is part of the screen transformer, so I've got my 6.3 and I've got an 18. So what we start off with, one side of the 6.3 volt transformer is grounded. Then that goes into the first diode. The diode's backwards of what you would normally see because we don't want positive voltage, we want negative voltage. And when you have to remember, when you do this, you also want to put the positive into the cap to ground, because the ground of the chassis is going to be positive. So keep that in mind. Your electrolytics have to go positive in, has to go to ground. So we come out of that diode, just a straight rectification there gives you about 8 or 9 volts. And that's added to the voltage that we get from the 18, and we come up with 59.8 volts. That is perfect. The fan needs at most 56, but we're going to tailor this down to what the tube wants at 55, so we've got a little bit of voltage we can burn off with a resistor. Real simple. And this circuit with the diode in the other direction off of here, because this is on ground, we get 25 volts for our keying voltage off of the 18 volt transformer. Real simple. So that's probably the easiest combination you can find. It might be hard to find an 18 volt transformer. If you have something that's different, if you'll just simply let me know what the AC voltages are, send me an email, and I will figure the circuit out for you and show you with a schematic how you need to hook up those transformers. I'd be glad to do that. So the other notes on here, all diodes are 1N4004 or 1N4007s. You don't need big diodes here. All the caps are anywhere from 220 microfarad to 470 microfarad. I chose those because it's a good common value and it gives you plenty of filtering to keep the hum out. The hold-off voltage needs to be at least 100 volts. So that would be at least a 470 at 100 volts. The 6.3 volt filament transformer should be at least 3 amps. The reason for that is the 4CX250B will draw 2.6 amps of filament current. So it needs to be at least a 3 amp transformer. The 12 or 18 volt transformer can be less. All they have to be is 1 amp, because all they're going to have to do is the bias, which basically is no current at all, and whatever the relays draw when you key down. That's the only current that's going to be required from that transformer. Okay, well, I'll get to wiring, and I'll show you the wiring when I get all done. Now, I have sent out 3 schematics just today, so that everybody that's on the list should have the new schematics, so you can follow along with this. And if you should want the full set, just send me an email. I'll post my email address at the end of the video. I'd be happy to send it out. So right now we're up to 24 schematic sheets in the set, and that's free. Anybody that wants them, just ask. And pretty much every one of these sheets I've talked about and explained and showed in the video. So once you have them in front of you, you can follow along, and it might help to kind of know what I'm talking about, so you can follow. Okay, we'll be back. I'm going to wire that chassis up, and then I'll show you the wiring that I did. Okay, we're back. What I just got finished wiring would have been on the schematic that you got, would be the schematic number 23, file number 23, the screen supply, with my 600 volt transformer. And what we're going to go through and show you is where the diodes come out, where the ground is. There's the 3 caps and the resistors that are across each cap for bleeders, and then it's wired up to the screen relay. And if you can, yeah, there we go. It goes to the top of the voltage divider stack and then hooked to the switch. So here's what we got. First, I'll show you where it comes from the transformers. We got the 2 diodes hooked to the first cap. These 2 white wires come from the screen transformer, which I have showed you before. It's mounted on the other side of the chassis, the top side, and it comes into these 2 diodes right here. Ties to the top of the capacitor stack. There's a bleeder resistor, the jumper between the cap, another bleeder, the jumper between the cap, another bleeder, and then it goes to ground. The wire from here, the red one, got it tucked under these little tubes, comes all the way up here, comes around to the, oh, you can't see it. Gonna have to change the camera angle just a little bit. Okay, goes up to the screen relay on this side, and on the other side of the contact it comes out. It's the orange wire. We come back through the tube. Now I'll have to turn the chassis, so I'll pause the camera while I do that. And it goes over here, and that screen resistor is sitting over here, and here's the switch. So we pause the camera and change the... Okay, I'm in tight quarters, so it's really hard to get this thing just to where I can see you. Yeah, I think we can see everything. Might have to move it just a little bit where you can see the switch. Okay, that stack of resistors is laying right here, and all the wires coming up from each section or each stage of power level, I got it tucked under these tubes again, and it comes on up here to the switch. I'm only using a 4-position switch on this one, so if you guys had 6, you could make use of one more. There's one more tap here you can see that doesn't have a wire on it, on that first resistor. So I'm just starting on the second one up, and then each one I drop in a wire all the way up. Okay, now we'll change schematics here. We're going to go to schematic number 23, and I'll be right back. Okay, got a little bit ahead of myself. I don't think I covered this subject in number 13, video number 13. But I know, call your attention, since we've built the bias supply, this information will be handy for you to know. This schematic was in the group of schematics that you already have. It's labeled, it's number 20, and I'm going to change the name on it and give you an update on it because I need to add some stuff to this. It's the voltage divider math example. That's what it's under, the label that you already have, and it's schematic number 20. This is an important part of the tube, you might say the tube's needs. You need to have a good stable voltage with a little bit of current drain on it, on the bias, the G1 grid. So instead of just putting your voltage divider out from, say, like a 24 volt transformer, where you'd have, out of a 24 volt transformer, you'd have 67 volts. It's a little bit high for what the tube needs, so we're going to take care of that and adjust it right down. This is an example of how you can do that. Start out, the ballpark number you're going to want to do is about 5,000 ohms. That wants to be probably a 2 or 3 watt. I've got this example of a 4K and a 1K because we're going to change the 1K to a different number, and I'll show you how to massage this number out to get what you want. So the total resistance, R1 plus R2, is 5,000 ohms. We got a 1K and a 4K. Current equals voltage divided by resistance. So the voltage has to travel across these resistors, and that makes a current. That current, in this case, is 13 milliamps, just a little above 13 milliamps. It's 0.0134. Now to find out what the voltage is across each resistor, just before you even measure it, is a little math, Ohm's law. And it's the current times resistance equals the voltage. So it would be 0.0134 times 1,000 ohms. And then we see our answer is 13.4 volts. That's what, if you put a voltmeter from here to here, you would measure 13.4 volts. And now we do the next one. 0.0134 times 4,000, and we can see that this matches our other answer. We get 53.6. This is what was left of the 67 volts. So we're down to 53.6 volts. So from ground to right here, this is where you would attach your bias lead. You'd have 53 volts. Now we're just a hair low if we want this to be just perfect at 55 volts. So now we can start playing with this resistor. We can drop this to, let's say, 850. So it would be 0.0134 times 850. I guess it would help if I'd wake up here and turn the calculator on. Let's try this again. Jeez. Okay, 0.0134 times 850. We get 11.39 volts. So, minus 67, that puts us right about where we want. That would be 55.6 volts. So we're at our 55 volts. Now, when you put a little bit of a load on your doubler supply, it's going to drop anyhow. So you would throw a resistor across there to get it loaded, and then make your measurement, and then you can start deciding how you want to play with these resistors. But this number should always stay at about 4,000. That's most of your work right there. The current won't change much. If we do that 55 times, we're doing wattage, that's right. So we'll do it the other way. 67 divided by 4,850. That only raises our current by 4/10, so it's 1.138 instead of 0.134. Doesn't raise it much, but when you're doing your math, that's going to throw you off if you don't use that figure. Okay, so you could use, instead of a 1K resistor, you could use an 850 ohm across here, and that would bring you. You wouldn't need to hook anything to here. Your interest in your voltage would be what this point is right here. That would be the 55 volts. Now, if you're using the little blower that I suggested from Surplus Center, its current is 1/4 amp. That's 250 milliamps. You would not want to tie that onto here because that would upset this. In other words, you wouldn't want to tie it because we got our 55 volts. The fan will run on from 48 to 40 or 56 volts. So, but you wouldn't want to tie it to here because that'll drop too much current across this resistor, and that'll drop this voltage way down more than what you needed. So you'd start out again, and I'll make another schematic up and then send it out the next time I have an update, and I'll just call it schematic 20A. But what that math would be is, since you know the current of the fan, if you're going to use the blower, it would be 0.25, and we'll say a resistor, throw a value of 50 ohms would be pretty close. So be 0.25 times the 50 ohms times the resistance, and that equals 12.5. So if we had 67, we'd minus 67, we'd have 54 volts. That would be just about perfect for the fan, and that would be a 50 ohm resistor, probably about a 2 watt. Well, I'll figure that here in a minute, and show you how you get that. But you're right at what the fan would love. Its limit is 56 volts, so at 54.5 you're right in there, and that would run right off of the 67 volts. There'd be enough current drop across 50 ohms to drop the voltage where the fan wouldn't be over voltaged, and that would be just a resistor in series with one of the legs of the fan. So now we want to know wattage. How big does that resistor have to be? So we'd go, we know it was, okay, I have to do that again. It was 12.5, I think. 0.25 times 50. Yeah, 12.5. Okay, times, that's the voltage times current, 0.25. We're looking at 3 watts. So you're going to want to use probably a 5 watt 50 ohm resistor. That resistor does not have to be non-inductive. It can be a wire wound 50 ohm. You can parallel up a pair of 2 watt 100 ohm resistors would work fine. 200 ohm resistors in parallel would give you 50 ohms, and the fan would be plenty happy with that. So I think that covers this, but this is your bias supply, and like I say, you need to have some current being drawn to make the grid voltage stable. It doesn't have to be regulated, it just needs about 10 or so milliamps, and with this circuit we're coming up with about 13, just a hair over 13 milliamps, and that's plenty, because the grid will never, or should never, be driven positive, and therefore the grid should not ever draw current. The grid won't draw current until it's driven positive. So unless you overdrive the radio, in other words, you figure the swamping resistor for a 5-watt radio, and you decide to try to run an 8 or a 10-watt radio, then you're going to overdrive the tube. So at that point, you would have to refigure your swamping resistor to bring you out. Your RF voltage needs to come out somewhere less than the 55 volts. You don't want your RF voltage over the 55 for the bias. The 55 volts is the target value for that 4CX250B. Okay, all right, now we can proceed to the rest of this video. Okay, there we go. I think hopefully that's in focus. Okay guys, I made a mistake on this schematic. I didn't catch it until I was wiring it up, and I thought, what? That doesn't right. Okay, it's suggestion B. It's the one I'm using here. This diode that goes to ground, that's wrong. I made the mistake of putting a ground symbol here. So you need to make a note on your schematic that this is wrong. This actually ties right down to that other diode and cap. So it doesn't go to ground, it goes over here. Because on a voltage doubler, you have to have each diode bridge the capacitor to get your voltage. And I didn't catch it when I was drawing the schematic up. So it's this diode, the one that's on the positive end going to ground. This is our bias. And then we have one going negative to the negative end of the cap to get our bias voltage. This end is wrong. It doesn't go to ground. It comes here and hooks to the other end of this cap. The positive end of this cap and that diode hook to the negative end of here. It's like stacking batteries. We're seriesing 2 power supplies. So on this one we're getting about 8 or 9 volts. And with this doubler we're getting about 50 volts. So we come out to 59. On the calculator it says 59.8. It's going to be a little bit different with the AC voltage and any transformer that you use around 18 volts. You're going to see a little bit. It isn't that critical, but it's basically going to be just right at under 60 volts. It'll be real close. So, yeah, make that correction. That ground symbol's wrong. On the next time I send out schematics, I will have that corrected, and you'll get a new, fresh schematic with the right way that it should be drawn. Okay, guys, that's pretty much wraps it up for video number 14. I'll give you a little look ahead. We're going to start throwing some switches together. This is the next schematic, number 24. And I'll walk you through the lights and the switches and the safety relay and all that stuff. You don't have to hook yours up this way, but I'm trying to show the most amount of tricks that you could use to make the lights and stuff really look nice on your rig. You have a fault light that turns red if there's something wrong with the high voltage. This setup also allows you to leave the high voltage off, so you can burn in a tube, or getter it as they now talk about. If you get an old tube that's been sitting around, you can plug it in there. The fan will run, the filament will run, and you'll be able to getter the tube, leave it turned on and running for about 24 hours or so. And the other trick is with only 4 switches, you get power on and off, you get high voltage on and off, you get standby, operate, receive boost on and off, and sideband on and off, all combined into just 4 switches. And I'll run through the tricks on that in the next video, number 15. Okay guys, thank you for following along. If I gotta give you my email address here. Watch, I've lost it. Ah, there it is. Okay. I'll discombobulate it here. Okay, guys. If you have any questions, my email address is radiomedic111@yahoo.com. And if you feel you're, get this in, back it out just a little bit. There. If you feel I'm helping you and you'd kind of like to help out, I'm not asking for donations, but I don't want to take this to like, what do they call it, Patreon. I want to put this out there where everybody can get it, even if they can't afford, you know, to go to Patreon. So any help would be appreciated. And if you need the schematics, if you're just new here and you haven't got your pack of schematics yet, just send me an email at radiomedic111@yahoo.com and I'll send you out the set. Right now we're at 24 files on the schematics. So thank you guys, and we'll see you in the next video, number 15. Bye now.